Hello, you see me again here. That is, my students is going to have they did have another test. So we're going to go through the question and let's share, happy sharing with the working and let's see the question with all of us. All right, so this is a 2-point question, pretty straightforward. This is a task which going on sequence and series. So let's get through those. So a sequence beginning with 8 and 2. Didn't say anything yet, but this is arithmetic. So which means that our U1, I will write down whatever we have first. So U1 is 8, U2 is 2. So arithmetic sequence, we have the D. D have to be the 2 minus 1. All right, and then we have 2 minus 8 that give us negative 6. Careful with the negative because some of my kids just forgot about it, didn't see the negative for some reason. And then we put in our equation, Y21 will be U21 will be equals to first term plus n minus 1 times negative 6. So that gives us 8 minus 120 and the answer is 112. Nice and easy piece of cake. And the next bit, let's zoom a bit first. All right, so if it's a geometric sequence, infinite sum. So U1 is still 8, U2 is still 2. But this time it's geometric, so which means that you want the common ratio R. Common ratio R should be equals to U2 divided by U1. So we have 2 divided by 8 equals to 1 over 4. This term is smaller than 1. So we could have an infinite sum. So we have U infinite equals to 8 over 1 minus 1 over 4. Here's the tricky bit, is fraction. So we will have 8, I will work on the denominator first. And because it's this fraction bar, that gives us 8 divided by 3 over 4. Normally, I will write all these. And then that will become 8 times 4 over 3. So multiply 4 to 8. So we got 32 over 3. And this is our first question on non-cal sequence and series. Oh, I forgot to mention. I'm using errors today from Blackwing with my normal eraser. Yeah, I like the way they wrote it. All right, until next time, we will have the second question very soon. Yeah. Hey, sorry for being the late start. All right, this video come with you, brought to you, and not brought to you. I brought by it myself. I did not get sponsor. So no, there's no sponsor in this video. I'm still waiting for it. Today's is Blackwing Natural and my normal eraser. Pretty good. Yeah. Anyway, let's get started. So we write down, this is a question about binomial expansion, basic expansion with the certain term. So we will have, first of all, we need to write down no step at all. So all you need to do is just fill the number, write down the number. So we know that the number of term is always the n to the power. How could I make sure they? Okay, right. So let me lock that. Oh, okay. So we know always the n to the power number of terms. You might need to remember that. Number of terms will always be n plus 1. So power 2, you got 3 terms. Power 3, you got 4 terms. So that's why we will have 12 plus 1 get us 13 terms. You don't even need a working for that because it's just writing down. So no working is it. But next one, find, and this 5 point we will expect to do as some workings. So let's see. So we want the x to the power 3. So we have I will personally like to set the r in the front. And then we have 1 over x squared become 12 minus r. These two numbers should add up to be the 12. We are finding out here, so no binomial required. So we have x to the power r times x negative 2 times 12 minus r. I usually skip this step. And we have x cubed equals to r as the x to the power r to minus 24 plus 2r. Compare the index that will give us r minus 24 plus 2r. So I throw everything on one side. I got 27 equals to 3R. R equals to 9. If you are letting this one to be R, you will get to have a 3, which is the same, which will give you the same result. So now next bit, we will have the 12, 9, x to the power R, and x, sorry, we find an R already. Hey, yeah. And then we have 1 over x squared to the power 12 minus 9. Give you 3, so it's 3 here. So that cancel out. We will have 12 factorial over 9 factorial times 12 minus 3 factorial. This is the formula that you can find it from the data booklet. X to the power 9, 1 over x to the power 6. Cancel everything out. So we have 12 factorial. No, I do not need the 12. I need the 9. So 9, 10, 11, 12. That is how we do it. Over 9 factorial times 9. So we got 3 there. So 3 times 2 times 1. This is what we need for the factorial 3. Now we cancel the 9 out. 12, 3, 2, 6 divided by 12 is 2. So now we have 20 times 11. So that gives us 220, x to the power 3. Again, be very careful because the question asking you for the term. So we not only to give them the term, like whole number, not just the coefficient. A lot of my student is a bit overseeing the word and just give me 220, and that is the wrong answer. Not fully correct, but you lost 1 point. We just don't want that to happen. All right, so until next time, we brought to you a longer question. Stay tuned. Right, so this is going to be a longer question because one question they're asking about both arithmetic and it's like a bit tricky on the sequence here. So we have a geometric sequence here, U3, U6, common ratio, and U1. So the zooming is not getting there. Yes, it does. So what we're going to do is I will do part 1 and 2 together. So I would really like the zoom to stay on. Okay, so we're going to leave this to stay on, and then we will have the bit with those. So we have I find the common ratio first. So -8, actually, I will do it the other way. So we have U3, U4, U5, U6, right? So I will have to have it 1, 2, 3. So if I have U3 times R 3 times, that gives us 3, which is which gives us our U6. Yeah. So with that, we will have the -81 times R cubed, that gives us 3. Rearranging it, 3 over -81, cancel that. So we will have R cubed equals to 1 over 27. So R should be -1 over 3. Once I find the U1, once I find the R, I can find U1. So U3, which is equals to U1 times -1 over 3 squared, because R minus 1. So we have a -81 equals to U1 times 1 over 9. Throw it to the other side, that gives us -81 times 9, just in case, 972. So we will have -729 as the U1 there. So with our U1 and U3, I can get my U4. So we have U4 there. And I am very lazy here, so I'm not going to use the original one. I'll use my 81 there. 81 negative times -1 over 3. That gives us 27. All right, definitely you can play around with like U4 equals to U1 -249 times -1 over 3 to the power 3. You are more welcome to do that, but it's a non-calculator, so I will try to save all the chance of making a mistake to somewhere else. So, and then we're going to move on to the next bit. So we've done all those, and then now we think of a new sequence. There we go. I got second page there. Oh, new sequence. Zoom, zoom, zoom. Zoom. Thank you. It's like voiceover, like sound recognized. All right, so we have AN will be equals to U2N. So when we have A1, then I should have U2. And A2, we have U2 times 2 is 4. A3, we should have U6. Since we have our U2 somewhere here, no, we don't. Do we have U2? No, we don't have U2. So we will have negative 729. Negative 729 times negative 1 over 3, that gives us 243. Yes, possible 243. Our use 4 is 7 here. 27, we wrote that down. Use 6, we have it 3. So all you need to do is just gather the information from it there. All right, so hence, so that this is happening. Oh, that is annoying. So we have n is already starting from 2. So our sum of n over 2 infinity, let me rewrite that first. So we will have starting from 2, n times 2 is 27. So I will have 27 plus 2, 3 times 2. They got 2. Oh no. We have 2, 3. So we have 27 plus 3 plus moreover with those. All right. So, and this we know that is double the, skip a term from there. So we will have our U1 equals to 27. R equals to negative 1.3 squared. That gives us 1 over 9. Because it's every 2 term we add 1. Still smaller than 1, we can perform a infinite sum. So that will give us 27 over 1 minus 1 over 9. A bit of a pain there. So we have 27 over 8 over 9. Divide means flip. So I have 27 times 9 over 8. We do a bit of the math. 27 times 9, 63, 18, 9, 10, 11, 12, 6, 11, 12. No, 唔係喎，3六1 18 19 20 21 22 23 24. Sorry, I count in 20s. So it's 2, 4. Huh? So now we will have 243 over 8 there, which gets you the equation. I showed that already. All right, this is our longer question brought to you by Bonnie Look. All right, we'll see you next time for the calculator section. Bye-bye.